Yeah. Perfect. All right, so let's start from the beginning. Is the first part is actually the data analysis and also setting up the environment connected to where your data folder is. I think we're beyond that stage. And we had 3 files, the trend file, the test file, and sample submission. We learned that the trend set is actually the one which gives us all the features, and also it gives us something like whether this person have this account or not, all the results, all the labels of 1 and 0. With the test set, what we had is actually all these features, but without information about whether this person has an account or not. And then we already know it, since we have analyzed it, we already know it's 2016 and June, every user here. So the encode per is basically the user code. Each number represents a user, and the test set, in the test set, the date is always June 2016, because this is the latest bank statements they have, and they were using that to evaluate the performance of our model. And in the trend set, which is really big, we had the previous information. So it's all the bank statement from before 2016 and June. So because it's quite big, we need to use the chunk size to read it bit by bit. And I'm breaking it here because it takes quite a long time to read 300,000 already. And we can see we have all these features with different codes, and also the results, starting from IND, probably an index, to show that whether this person holding this account or not. So then we were thinking, okay, to have this, we want to visualize the data a bit. So we were looking at, okay, maybe we are looking at the age, what the age looks like. And I'm checking, okay, what's the type of this data? Right here is an object, and I can turn this into a string and then turn this into an integer, but I cannot turn this object into integer again directly. It's probably associated with how it was, how this data was actually saved, the format. So we need to have a look of all the format to make sure that we can turn this into some numerical values. And then we were having a look and realized there's some non-value, which is NA here. And if we're turning this into string, we have a lot of space, and we can turn that into integer, and we probably need to remove some of the space. Sometimes we do not need to. That's a little bit like processing inside. And because it's NA. And in this case, I'm turning all the NA into 0. I'm just saying that age is 0. Another way to deal with it was that we can actually calculate the age distribution, a histogram of the age. We can look at it, what's the mean value of the age, and or maybe I can find the age which has the highest density, like the most people maybe are aged 34, so I can assign my non-value into 84 or something. And then we were looking at, okay, how the age is associated with whether this person has a pension account. And we took just some like 300,000 data. And we can see that, okay, if this person is a new customer, he's probably not going to have a pension account. And we know in this case, by looking at each feature and the result, the label we want to trying to figure out, and we know whether they are related. It seems like this is related. So this is an important feature we need to include in our analysis. Yes.
What happens after age, like, is it at age 65, your pension account turns into a regular account? Wouldn't they keep their pension account?
So what we are looking at here is, in this 300,000 data, no one above age 65 actually owns a pension account. So it could be because people above age 65, they don't hold a pension account. They probably turns, as you say, turns into some other account. That's possible. Another possibility is that in these 300,000 rows of data, we did not observe that. It's possible that it exists in the other data sets. So we need to actually extract all of them. What we can do is, because we're just looking at the relationship between age, new customer, and pension account, we can just extract the 3 columns from the trend set, and that is going to reduce the whole data set by a lot. And we can just extract them like chunk by chunk, and afterwards we can plot the whole thing. So that's something we could do. That's one method of dealing with that, is extracting all the data out and plot it in one go. Another method, which I haven't done it yet, is you can read chunk by chunk all these data sets, getting the information you need, paint it on this figure. You read the next chunk, paint it on this figure. There is a method to paint dot, and then paint a dot again, and paint dot again. So basically you're painting on top of this figure to do something you want to do. It depends on what you want to do, basically. If you are just trying to look at these features, sorry. I think the Y table is like, thanks. So if you just want to look at the relationship between these 3 features, you know what you want, then you can just run it, the whole thing, and extract all the data out. And afterwards you can play with it like whatever you want. In another situation is that this, I'm just looking at it randomly, I might want to look at something else. So going through the whole data set again and again will take a large amount of time. I do not want to do it. So what I can do is I can just paint everything I want to paint over here, and then save the file separately, and then read the chunk again and paint everything. Like, it depends your what you want to do. And because when the data set is really big and takes a long time to compute and to visualize everything, we need to consider what is the most efficient way to actually view them or even process it afterwards. So, yeah. And then we can move on to the next one. I hope everyone can still see. Yeah. So we also look at something else, like whether the gender is related to whether this person hold an account or not. And we'll consider maybe not, because it seems like equally distributed. And then we want to look at the income. And then we realize, okay, the income is actually, the majority goes around, I would say, over 0, while there is like some individuals, the outliers we call, are actually having the income of 25 million, which is, we can't see what the distribution look like. So in this case, I'm thinking, okay, maybe I can plot something in log way. In this case, we can see where the distribution sits. We have the mean value, we have the variance, or we have the median as well. So we know how we should transfer this income value into the other numerical value, which we can, which would be equally spaced out in the analysis or in the machine learning model. So the first stage is just visualize different types of data to see how they are related to each other, and whether the payroll account is related to the household income or something like random things, just to have an idea what the data looks like. And then we move to, once we know what it is, we know that, okay, some of the features are actually related to the result, to the label, to whether this person hold account or not. Then the next stage is like, I need to consider, okay, my data set is not perfect. It would have non-value. Do I need this non-value? How many non-values it has in this data set? How do I deal with it? And something like, okay, some of the feature is that important, like country residency. is that going to be important? What does the start date means? What does a new customer means? What's the seniority means? Or can I deal with it? How do I deal with it? So we had a look of all these unique values in each feature and think about, okay, what do I want to do with it? So by looking at these, I was thinking, okay, with the gender, I can turn this into 0 and 1. There are some non-value. With the age, I can use the standard scalar to transform that into a value between -1 to 1 or 0 to 1, like in this range. As long as it's not far off, as long as every other feature is between 0 to 1 and one of the feature goes to like 150, that's a bit too much. Like it's not balanced features. So I need to shrink that. At least it's like maximum is like 4, then that's fine. That's reasonable. Then I say, okay, I'm okay with that. So there's a lot of things. Then what we are trying to look at is, okay, how many non-values in this case? And in the 300,000 data set in the first chunk, I'm just checking out. Okay, so a lot of these non-values are 3,249. So which means, from what I'm thinking, is probably for these 3,249 rows of samples, they don't have any information. They don't. So probably one row doesn't have any information. That's why these numbers are quite similar to each other. So I'm just removing when I choose gender. So gender is somewhere here. So I'm just choosing a random column saying random feature saying that I'm going to delete this 3,000-ish feature. And then everything goes to 0, which means they are sharing the same row. These non-values are sharing the same row.
Sorry, I didn't understand that. What is, so you selected the.
Yeah, I'm selecting gender. I'm just choosing. Yes.
Okay.
So I can draw it.
Drop.
Yes, yes. So I'm just dropping the row, which is none for gender. So once I'm just dropping that, and it turns out all the others, like non-value, are gone. This is because they were sharing the same row. So in this case, I don't need to worry about that because these 3,000-ish rows, they don't have any features. It's not going to be helpful to my model, so I can just drop off them. And then I'm looking at the primary date and the spouse. That's about 300,000. And I know that I have about 300,000 data set, which means they don't have the bank doesn't have any information about spouse, our primary date. So I don't need those 2 columns, those 2 features. And then I'm just looking at, okay, province corresponds to the province name. So I only need 1 feature. And because it's only 400, so I'm thinking, okay, I'm not going to be bothered with that. And also with income, we have about 50,000, and that's quite, I would say, large number of sample. So instead of deleting that, I'm thinking, okay, I need to fill in some value, which is a reasonable value. So what I did is like, I'm choosing the mean value, and the mean value is not chosen just by the mean of every sample. I'm choosing it by individual customer, because some customer has like 17 rows of data, some customer has only 2 rows of data. So this income could be replicated in some case. If the customer has like, let's say one customer has 100,000 of samples, then this person's income would actually be the majority, might even be the mean, but I don't want that to happen. So I'm calculating for every customer, like just customers. Each customer has 1 income input, and I'm calculating the mean of that, using that to fill in my non-value. So several ways of dealing with this kind of non-value, several ways to transform the data set. Yes, and also with the I introduced some of the method to, if you have so many, like this many, the province code, they're like goes from 0 to 50 something. And then how do I turn that into a value? Either I can turn that between 0 to 1. I could do that with a standard scalar, or I could just minimum and max scalar. There are several scalar on scikit-learn, and we could deal with. And the method I'm doing here is I'm turning that into a kind of like a binary encode. So what I did is like with the binary, like it's a little bit like bits. So with 1 bit, you can represent 0 and 1. And with 2 bits, you can represent 0 to 3. So 2 to the 2, and then 2 to the 3. So with 64 numbers, I can use 8 bits to represent that. 8 or 7, probably 7. I think, yes, probably 7 bits, sorry, 7 bits to represent 64. So in this case, I could use 7, I would say features. Each feature is 0 and 1, and use these 7 features to represent another number. This way, it introduces more features. That could be quite dangerous if you are dealing with like smaller features. So don't use that when you have like limited amount of features. But in my case, I have probably 25 or I already have 25 features. So adding the extra 6, I do not see how much damage it could have. That's why I didn't worry about that. I don't think I added in the end, but it could be something you use. And then we want to understand the input. This is actually the first step to understand the input, but before we do not know how to deal with it, we do not understand the data, it's also important to actually have a look of all the data and to see what they are like. And then I got a little bit idea and then go back to the input to see what they mean. And then if you don't understand, go to visualize, it's kind of back and forth process until you understand what it is trying to do. So in this case, we understand that in the test file, we have in this test file, what we found out, in the trend set, what we found out is that we have like 13 million rows, but the unique customer ID is only 900,000. So some of the customer actually owns multiple numbers of rows. And then some of the customer has over here, some of the customers has 17 rows, some of the customer has only 2 rows. And if I'm calculating how many customer has only 1 row, how many customer has 2 rows, I'm just printing this. So about 10,000 customer has only 1 row of information, and 7,000 customers has 2 rows of information. And then I'm looking at the test set. What we realize on the test set is that in the test set, there are 900,000 rows and 900,000 customers. So each customer only has 1 row. And then combining with what we learned earlier, so all the test set is 2016 June. And if we look at the trend set, we realize all these data are actually before the June 2016. And if I'm just picking the information from one customer, we realize it's kind of going from maybe like June 2015 to May 2016. So it's like a bank statement. That's how we start to learn, okay, we are having the previous information. We are predicting for the 2016 June, maybe it's the newest information. That's what we start to learn. And that is also associated with how I actually split the data, because when we start to run our model, I want to know how my model behaves. How can I do that? If I'm only training with my trend set, I don't have the result from test set to actually evaluate my model. So what I need to do is I need to split the trend set given by the website. I need to split it in the same way that the website splits it. So what I did is for each customer, I'm choosing the last row from the trend set. and extract that out, use it as a test that I am using. So in this case, I have the account information they have, and I can use the rest of the data to train my model and use the extracted data to evaluate how my model behaves. So in that case, if in the train set, the customer only has one row, I can't do it because I do not have a train set to predict for this customer anymore. So I'm basically deleting all these one row of information later. But this is just to help me to understand what the model behaves like when I'm submitting for the website or for the competition. I do not need to evaluate the model anymore. I know this model works, then I can use every data I have to train my model. Okay, is it confusing? Is everyone understanding it?
I mean, it makes sense, but I wouldn't have thought about doing something like that.
Yeah, like okay, it's a bit with experience, like if you're dealing with
It makes sense, but
yeah. So luckily for you guys, I have already split everything and saved them in the data set. So save them in a file. So we're good. We can just use it directly.
Yeah, it's also taking me a moment to wrap my head around like how you do the np.unique and you again. Like I think there was one. I'll go down.
There's a unique here.
If you go down to the where you count how many rows each.
This one.
So you see info equals np.unique. And then there's another np.unique. And just a little slow trying to. Understand.
It's okay. Like I'm just thinking like you don't need to read the code. I want you guys to understand what I want to do. And then code is just like it's a little bit confusing, but like it's just this is the target, and then I'm using code to try to achieve this target. I'm just putting that into one line, but for you, you can just separate them into different lines. They are like little small steps. The first step would be I want to see each customer ID, like how many rows they have, and that's my first step. The second step would be okay. So one ID has 17, another ID has 17, another ID has 17. So how many IDs have these 17 rows? And then you can separate them into different lines. So start with that. It's also easy. It's also called clean code. I have this bad habit about putting everything in one row, and I don't want to separate them. But it's a little bit hard to actually for other people to read it. It's a bad habit from me, actually. So don't need to worry about this whole like complex one row. It shouldn't work like that. So if you see this line over here in the middle, that's a line that says that you should not code beyond this line. And I do that a lot. So that is counted as a not very good coding. It's not a clean coding. Yeah, but I wasn't bothered too much because it just went beyond the low bets. I think I can see some, oh yeah. Okay, yes, just repository. Thank you, Eka. So yeah, this is the same basically. I'm just checking because I'm looking at the number of I'm just looking at the number of customers and the number of rows. I'm wondering, is that actually one customer corresponds to only one row? And I'm calculating that as well. It's just a question, and I'm trying to answer it by coding to get the answer. So yeah, and then I'm trying to see, okay, even though they both have like 900,000, like exactly the same number of unique customer ID, but are they actually the same customer ID? It is directly from the data set. I said, yeah, it looks like they're the same, but I need to confirm it. So I did the intersection to see, okay, the number which they intersect is like exactly the same number. So that is the same ID. And then I probably didn't show it here. And I extract one customer ID from the trend set and the test set to see if that is actually the last month bank statement. So that's what we did. Then we know that we understand the problem. And then we need to, we understand the problem, then we need to see, okay, what kind of feature do I need? I get the whole picture of the problem. I get the picture of what kind of feature I need, what kind of role I need. And then I'm just looking at, okay, what is the label like? For each label, I'm just choosing one label to predict, because if I'm choosing, like, they have probably 20 or 24 labels. To deal with 24 labels or 12, I can't remember how many, but to deal with all of them at the same time, it's a very complex problem. So I do not want to complicate my problem. I want to simplify problem. I can predict for each column. So I'm choosing one of them as a label, as our first step problem. If I want to do all of them, what I can do is, if there are 12, I think 20, probably 24. If there are 24 of them, I'm just going to create 24 models. Each model is a binary classification to predict 1 or 0. And it doesn't matter, like I'm dealing with it one by one or all of them together at the same time.
So if you did that, the other, like if, let's say it's 24 products, you, like one product would be the target, and then
Yes.
the other 23 would be part of the training?
No, because if you remember, for our test set, we do not have any information, so that cannot be used as a feature.
Okay.
So I'm just going to have all these features, and I'm also going to use just one label together to predict to feed the model. And then after understanding that, then I was thinking, okay, is there anything else I can do? So apart from the feature, I'm thinking, okay, whether I have, because I understand all the training data set, all the information I have is about previous, I have all the previous information. So the thing would be, so if this person has account, is that related to whether they have account before, or is that related to whether they had the previous account? So I have all that information. Even for the test set, I have all that information. I can create new features from that. I'm not limited to the features they gave me. I can create my features. I think they are definitely related. If this person has owned this account for past 6 months, I don't think he will drop this account. He will probably continue holding this account. So it will help me with my prediction. Then I'm thinking, okay, I'm going to add features saying that in the past 1 month, this person hold this account. In the past 3 months, whether this person hold this account. And in the past 6 months, whether this person hold this account. How do I calculate that? I'm thinking, okay, in the past 1 month, it's 1 or 0. In the past 3 months, I have the information from the past 3 months. I'm going to calculate the mean value of that. In the past 6 months, I'm calculating the mean value. I'm only choosing 6 months because some of the customer doesn't have 6 month information. So I don't want to go too crazy about it. And also whether this person has like 10 accounts in his 10 accounts probably matters, because with 10 accounts, they probably just continue going for another account. So I'm calculating for all the accounts as well. That's how we are adding features here. Over here, there is add features. You do not need to run this block, because as you can see, I'm basically separating all of that. Because the data set is too big, I'm using I'm using several scripts to run the whole thing. So I already added the feature. You don't need to deal with that anymore. It takes like days to actually do that. So you don't need to run it. But I want you to understand how this was added. And what matters will be how I actually added the features over here. I'm calculating the previous few months, previous 3 months, previous 6 months. And how do I calculate for the total? So this is I'm dealing with for each customer. I'm extracting each customer. And for each customer's information, I'm extracting for each month. So there are two loops here. The first loop is loop into each customer. And the second loop here is looping into each month of this customer, because for each month, I need to calculate the previous month. So that's information. Even though test set doesn't have previous month's information, like we have that in trend set. So we can create that features for test set as well. And in the future, if they want to predict for another month, they can have that. The bank can actually predict because they have the past information. So they can introduce this feature into the future prediction as well, beyond the test set. I hope I'm good with time. I think I spent quite a long time talking about the thing. So the pre-processing is basically what we discussed in the first 4 sessions. And I'm just basically doing that and changing all this, dealing with the non-value and dropping some of the features I don't think that which matters. And also removing the non-value and changing everything into numeric value. So this, after adding feature, which you do not need to run, I was pre-processing, change to numeric values, and saved everything into numeric value. So saved everything into trend set numeric value. And then I was splitting the trend test, as I mentioned, because I want to evaluate my model. So I'm splitting that into trend set split test and trend set split trend. So I think this might cause a little bit of confusion because I was trying to deal with it in a different script. In this case, it's faster because that takes hours. So do not run it. It actually takes hours to run this whole thing. So I cut it out small batches, call them mini and small batch. If you go into the folder, you'll be able to see it. And then what we do is prepare the input and output. So the trend set split trend small batch extract everything, like the first, I'll say I think I went from, yeah, this, the second column, third, this is third column. So starting from third column, I think the first 2 was, one is customer ID, one is the bank statement. I didn't include the date. I don't think that matters, but there is also, if you want to include that, can be included as well. So that's all the features I think matters. And everything is a numerical value. And also I have my added feature from feature 1 to feature 7. And my last column is my label. So I'm not showing it here. So I'm only showing the features right now. And the last column is the label. And then I'm extracting the same way with my test batch. So over here, that's the test batch.
Label means which product?
Yes.
You pick one of the.
Yes, I picked one of the products. And we should have a label here, like to show which product I picked. In some way. Yeah, probably somewhere actually earlier. So yeah, and then it comes to the model. Support vector machine, actually, I did not think about that because support vector machine actually takes a very long time to run. It is very good if you have a smaller number of samples in your data set. But when the data set gets bigger, it is because it needs to loop into every data set and just continue looping. So it is easily trapped inside this algorithm. I'll probably add not suggested. Takes a long time to run. I haven't managed to actually finish the whole thing. I received a message saying that someone run it for 5 hours and didn't actually finish. So
I stopped mine after 20 minutes. I didn't know if it was going to be hours.
yeah, someone tried it for 5 hours and didn't finish. I was suggesting not to continue with this. Yeah, because it's not worth it. And especially with scikit-learn, and if because they're not printing what progress they are with. If you are dealing with neural nets, we can actually print out the progress, so you know which stage it is. Right now, it's just endless waiting, so I would not suggest to do that. I added logistic regression, and in logistic regression, there is basically a maximum iteration you can go through with scikit-learn, and it could not converge after 100 iterations. So I changed it to 10,000. It doesn't take long. And even if it takes long, it will stop at 10,000 iterations. So it will definitely have a definite end. And so I was testing with that. And we can see, I was testing with the small batch, which is the medium, but like 100 something megabytes. And I have accuracy of 0.97, which is 97%. But does that mean anything? The thing is, from observing the label, I noticed that for some of the count, it's very rare to see a 1. It's always a 0, most cases. So in this case, precision doesn't mean it is good. And also, yes, because it's very unbalanced, because there is very little 1 and a lot of 0. That's why we added the class weight to be balanced, because it's unbalanced data set. Be very careful, and unbalanced data set in our case, it's quite lucky because it doesn't affect the whole thing like badly or much, and we can still deal with that. But when we are dealing with balanced data set, just be very careful, and we need to observe what the result is like. Even though you get a great precision, it doesn't mean it's a good result. What we need to look at is something like RC curve, and which is a true positive rate to the false positive rate. We need to look at the confusion matrix. So first thing, let's have a look of the confusion matrix. This is the focus of this week's work, is that we have the true label here, 0 and 1. We have a predict label here. So if you're comparing the true label, the 0 has about 90,000 values. The 1 has only like 10,000 values. So it's a ratio of 9 to 1. It's very unbalanced. I won't say extremely unbalanced, but it's quite unbalanced. So when we'll add true value, basically the first row, and then the second row is positive. So we have like only 10,000 positive and 90,000 of negative. That's unbalanced. So in this case, think about if it depends on which part does the bank values. So if I have, well, not bank values, if considering our, let me draw over here, where one can see from the camera. So you guys are showing up the camera as well. So in our submission, what we get is like, okay, so if everyone remembers the submission file, they have a custom ID, let's say 2589 something. And then what they want us to have is, what they want us to have is the string of product 1. Whether this product 1 has been added or product 2. So if 2 products were added, then we put 2 values here. If only 1 product's been added, we only put 1 product here. So what is added in the previous months? Let's say for product 1. Let's say in May, it is 0. In June, it becomes 1. That's the product added. If it already been 1, and then it's still 1, it's not added. It doesn't count in here.
Are you talking about the added underscore products in the submission? or-
Yes, added product that's in submission. So that's what the website wants us to submit. So that's what the values. If it's 0, we recognize, and if it's 1, in June it's 0. It won't be showing up. If it's 0 and 0, it doesn't matter either. So the only thing matters is here.
And if they didn't add any products at all, is it just an empty string or?
Yeah, it's just empty. So that's what they want. So in this case, we know only this case matters. So what we need to know is that we need to have positive, predicting positive matters. And it can either be a true positive. So true positive would help with the results or our rank in our competition. True positive would like help. False positive, which is being negative, it should be 0, but we predict it to be 1. That's going to damage our result, right? So which is false positive is going to damage our rank. But what about negative? Whether we predict it as negative or not, it's not going to affect too much about that. So in this case, we want to have the true positive, as many true positive as possible, and as less false positive. So it depends in each application. The thing what they want is actually different. So in your case, in our case, we want true positive and less false. And then, so how do we see? We have a true positive rate and false positive rate. So we want to be as close. Oh, no. Sorry about that. Let me. Okay. Yes. So we want to get close. So we want to get close to this side, like less positive rate and higher true positive rate. So get closer to this side. But for unbalanced data, we shouldn't look at the rate because the rate doesn't actually, because the basically the base number is different because unbalanced, they're very unbalanced. So the rate doesn't really mean or doesn't give you great indication. So what we need to calculate here is true positive numbers and false positive numbers. Have a look at both. If you don't know how to choose, but have a look at both of both, it will give you, by looking at both of them, you would be able to see kind of having an idea, and also looking at this confusion matrix, we will get an idea about what it's like. And also with precision and recall. Over here, so far it's all right. Over here, it doesn't actually, I use it much less because we get the precision and recall, like kind of, you get these kind of information from the confusion matrix, also coming from the RC curve as well. But it depends, in some cases, you might need to look at the precision and look at the recall. That's how you compare these. And so by looking at this, remember all these numbers, they are the same test set. So we have this false negative, false positive as 504 and 2451, right? Now I'm trying to tune my model to make sure I have a better result or something. Like I'm changing the hyperparameter in each model. So what is the hyperparameter? Logistic regression, I have class weight, maximum iteration. There's so many more parameters I need to tune. To be able to tune this, you can either randomly tune or do a grid search, just run this many times, try with error parameters to see how that works. Or if you understand the algorithm, how the mathematics works, you can tune it with a purpose. Because grid search requires a large amount of computing time and power, and it doesn't necessarily give you the best result. You can't explain the result. But to start with, you can just test it randomly. But eventually, it'll be really nice to learn whether you are tuning this parameter. If the parameter doesn't work, and also have a look at the result, understand the geometry of your data set, and then you will be able to tune different algorithms, because this algorithm might not work with the geometry of this data set. So it's kind of step, like first of all, as a beginner, I would suggest just test with this. At least you can run something, you can get something out. And then you learn how it works and how you choose different models based on different data sets. So here I'm choosing like a random forest. And remember this figure, I'm not saving it right now. And I'm going to run it again with random forest. It shouldn't take probably a minute to run. So earlier I get a accuracy of 97%. Here I got 99.9%. Oh, that works very well. The RC curve almost went into this perfect square, half square shape. And then I have a predict label like this number has been reduced dramatically. So, and also we have a perfect precision recall display as well. Precision recall curve as well. So that works very well apparently, just by simply changing the algorithm. Random forest actually, I do not, to be honest, I understand the algorithm, but I do not understand why random forest normally works really good with a lot of data set. So random forest is starting from decision tree. Decision tree evolves into different branches. It goes to like ADA boosting, gradient descent boosting as well. They are all involved from decision tree. In the field, it has been proved to be very useful in a lot of cases, and it's quite efficient. When we're dealing with regression problem, like having continuous value, it takes a very long time, but it proves to be quite, I'll say, quite useful in most of cases, unless it requires something dealing with like image, video, or voice, or like a time series signal. They have different purpose. But with this general case, anything tree related seems to be working well. So that's something you could try on. But I don't know much about it, so I can't tell you when you should or should not use it yet. So yeah, that's basically the case. By looking at all these, you can start to tune your model, either changing the algorithm. There isn't much to try with, like to start with, like there isn't much algorithm to test it. There's only a limited number of model. What is complicated is changing the parameters. So it depends how great you want your model to be. So yeah, have a try with your the data set to see if there is a problem. And also, because this is our last session, if there is a problem in your code, let us know and we will try to solve it on site today. I think how to know which algorithms would be useful depends on the first impression, like what kind of data set you have. If it's an image, convolutional neural nets. If it's a time series data, normally it's recursive neural nets, something like that, because that is generally being used for something like for that purpose. And also depends on how big your data set is. If you have a big data set and you have a limited number of features, and sometimes linear algorithm works the better, and depends on what your feature looks like. Is that going to be 1 and 0, or is that discrete numbers, or is that continuous value? And depends on what purpose you have. Like there are so many things to choose. I would suggest to find something like called machine learning algorithm cheat sheet online. There's so many people creating these cheat sheets. So that will give you a general guideline about which algorithm to use. But to need to know better, within that range, to understand which algorithm to use, I would suggest you need to have a look of the geometry of the data set, and also understand like a little bit about the mathematics algorithm and statistic learning theory to understand how to deal with the data. But that to start the whole process without theoretical backgrounds, start with the engineering part and learn more. I'll say as you will encounter these problems if you start working in this field and then learning along the side.
Logistic regression, is that you said it's for if you have 0 or 1?
Logistic regression, yes. Or -1 to 1.
Oh.
Yeah, they were, I think the algorithm was using to differentiate -1 to 1. But you can use 0 to 1, 0 and 1. Okay. Sorry, not 0 to 1, it's 0 and 1. All right. For people online, please let me know if you have any so hands-on practice side. Yes, Kaggle is pretty good. So this whole challenge is actually got from this whole challenge is extracted from Kaggle. It's a Kaggle computation, and we're just using that. Kaggle also gives you a lot of I'll say tutorial to follow, and a lot of participants have a great notebook you can follow as well. Did anyone run into any coding problem?
Haven't anyone, it's just sort of I'm behind. So
No worries.
I'm just like here, like probably missing values.
Yeah.
So I was doing these, but it's
What is it?
Gender was
passed. Must be called with functions. Have you tried the column?
Because when I had
The name of
it was before all
You have
the
the
gender
gender.
stuff, and that like the earlier ones.
Yeah, you have gender, so
Yeah. Yeah.
and you're dropping the gender child.
It's
okay.
And that's kind of the same.
One is that. Oh no, but you have the number.
And I was
Extracted
like,
so
and that was so.
let me first.
Who's in the
I can see a question from Cynthia. So we are running this kind of, I would say not like too regularly. We had one competition in 2022, and this is the 2023 version. I'll think about how popular this workshop would be. Maybe would invite different people to start talking in different topics as well, because we want to keep the competition or the task to be different in each workshop. So yeah, like just keep an eye on our machine learning channel. If there is something coming up or something we are arranging, we would post it on the Slack. And also if we want to participate in this workshop, and we also have a volunteering channel which you can help with as well, and probably help organizing or thinking about the task you would like to solve as well. I hope that answers your question.
All right.
Hi, thanks. I joined from Meetup. I don't know if this is your only presence. So the channel that you mentioned, is this just Meetup group, or you only do this through Meetup, or you have other?
We have a Slack channel. If Eka or Silker are online, can you please post the Slack channel link?
Okay,
Yep, I'll get that now. Yep.
thanks.